Hello, hi. This is Priya, your maths tutor, and I welcome you all on my channel, Vidya Lee. So, in the last session, we have started chapter 9 of the class 9, and in the chapter 9, we have already completed exercise 9.1 and the theorems related to exercise 9.2. And we have already started completed question number 1, and now we're going to start question number 2 of exercise 9.2. So, let's get started. So, in the question number 2, we have if two equal chords of a circle intersect within a circle, prove that segment of one chord are equal to corresponding segment of other chord. So what we need to prove here, we have given the two chords of a circle which are equal and the two chords are intersecting within a circle. So we'll take the two chords PQ and RS, which are the equal chords. Here, PQ and RS are the equal chords intersecting at point T. Now, what we need to prove? Prove that the segments of one chord are equal to corresponding segments of other chord. That is, we need to prove that this is a one chord, this is another chord, and this is a segment for the one chord, and this is a segment for the other chord. So, we need to prove that this PT is equals to corresponding segment of other chord, that is RT, and TS is equals to QT. We need to prove this part. So how we are going to prove this? So for that, we have just drawn a perpendicular from the center to the chord, right? And we know that perpendicular drawn from the center to the chord, first of all, bisect the chord. And second thing, the length of these perpendicular is equal if the chords are equal. And we have given the chords are equal. So that is herein we have OU is equals to OV. So we'll try to prove OUT and triangle OVT congruent will prove congruent. And then after proving the congruent, what we'll do, we will try to prove PT is equals to RT, TQ is equals to TS. All right. So let's get started. So first of all, we'll write what is given in the question. So in the question, we have two chords PQ and RS which are equal. So we have given two equal chords PQ and RS which are intersecting each other at point T. Intersecting at point T, right? Now, what we have drawn from our side, that is a construction, and we have drawn perpendiculars. So that will be the construction, and that is the given part. So the construction is draw OU perpendicular to RS and OV perpendicular to PQ, right? And the next we have drawn join OT. Now we'll prove. So what we need to prove? We need to prove that PT is equals to RT, right? So what we'll do, we will take triangle, this one, O, T, U, we'll take this triangle and triangle O, T, V, and the next triangle we have is O, U, T, O, U, T. Now in the two triangles, we know that OU is equals to OV. Why these are equal? Because these are the perpendicular drawn from the center to the equal chords. And we know that equal chords of a circle are equidistant from the center. We have learned this theorem. So we'll write a reason here. Equal chords of a circle are equidistant from the center. From the center, right? Next we have OT is equals to OT because it is common in both the triangles. And the third we have angle OUT is equals to angle OVT is equals to, both are equal, each 90 degree, right? Now, we have proved that the two sides and one angles are equal and that angle is a right angle. So that is the two triangles are congruent. Triangle OVT and triangle OUT will directly write these are congruent triangle by right hand side congruence, because herein we have proved the right angle equal and the two other sides of a triangle as equal, right? Now, we know that when the two triangles are equal, their corresponding parts are also equal. So that is here VT is equal to UT, right? So VT is equal to UT by CPCT, corresponding part of congruent triangles. And we have given that PQ is equals to RS. The codes we have given are the equal. PQ is equals to RS. We have given this. If both the codes are equal, the half of codes are also equal. So that is half of PQ is equals to half of RS. Now, half of PQ is PV, half of RS is RU. So that is PV is equals to RU. We'll mark it as equation 1 and this as equation 2. Now, just have a look. So first of all, we have proved that this part VT is equals to UT. And next we have proved in the first one, PV is equals to RU, right? And if I will add both the equations, we'll get RT is equals to PT, what we want to prove, right? So adding 1 and 2 will get PV plus VT is equals to RU plus UT, right? Now PV plus VT is PT is equals to RT. So this is a one segment that we need to prove. And the next we need to prove that TS is equal to its corresponding segment, that is TQ. Now we know that PQ is equals to RS. We have given this. And if I will take away PT and RT from PQ and RS, we'll get TQ. So what we'll do? We'll mark it equation 3. All right. Now subtract PT. From PQ will subtract PT. That is, if I will mark this as number 1 and this is number 3. So subtract 3 from number 1. What will get? We'll get PQ minus PT is equals to RS minus RT, right? So PQ minus PT, we have TQ. So we'll get TQ. And similarly, RS minus RT is equals to TS. So RS minus RT is equals to TS, not RS. And this is what we need to prove. So in the first string, we have proved the one segment. And this is a second segment that we need to prove. So we'll mark it as equation 1 and equation 3 and equation 4. So this equation 1, 4, 3rd and 4th are the required segment that we need to prove. So we'll write, hence, proved. I hope it is clear to everyone. Wonderful. Now, the question number 3 we have, if two equal chords of a circle intersect within the circle, again, like the previous one, again, we have given two equal chords, that is PQ and RS are the two equal chords intersecting at point T. Now we need to prove that the line joining the point of intersection to the center makes equal angle with the chord. That is, point of intersection to the center. If we'll draw a line, this line will make equal chords at the center. That is, we need to prove equal angles with the chords. So we need to prove that angle OTS is equals to angle OTP or OTU. Okay. So again, like in the previous question, we'll try to prove both the triangles OVT, OU2 congruent, and taking the corresponding parts, we'll get our answer. Okay. So we'll write two equal chords. We have given the two equal chords. Two equal chords PQ and RS intersecting at point T, right? Now, what we'll do? Again, we'll draw the perpendicular. So that is the construction. Draw OU perpendicular to PQ and OV perpendicular to RS and join OT. Now we'll prove that angle OTV is equal to angle OTU. So for that, again, take the triangle angle OTV and triangle OTU. Like in the previous question, again, we'll prove the two triangles congruent. So OV is equals to OU. Again, the same distance, same reason, equal chords of a circle are equidistant from the center. Okay. Now, the next we have is angle OVT is equals to angle OUT. Both are 90 degree, each 90 degrees. And the third we have is OT is equals to OT common. So using the first three equations, we'll get triangle OTB is congruent to triangle OTU. Again, by right hand side congruency. And we know that when the two triangles are congruent, their corresponding parts are equal. So angle OTV is equal to angle OTU by CPCT. And this is what we need to prove. We need to prove the same thing, that this angle is equals to this angle. That is line joining the point of intersection to the center. That is this OT makes equal angle with the chord. Will make equal angle with the two chords. So we have proved the same thing. Hence, proved. I hope it is clear to everyone. Wonderful. So the next question number 4 we have is, if the line intersect two concentric circles, that is circle with the same center, with center O at A, B, C and D, prove that AB is equals to CD. A very simple question. So we'll solve just in 2 steps. So herein we have the line joining the center to the chord, and we know that this is a perpendicular, right? And the perpendicular drawn from the center to the chord bisect the chord, right? So herein we have BC, the chord of the smaller circle, and AD, the chord of the bigger circle. So first of all, what we'll write, what is given? So we have given the two chords, first AB. No, AB is not the first one chord. BC is the chord of the smaller circle. And AD, chord of bigger circle. All right. Now, what we need to prove? We need to prove that AB is equals to CD. So let's start our proof. So first of all, we can see that here the perpendicular is drawn from the center to the chord, and perpendicular drawn from the center to the chord bisects the chord. So that is, we have BM is equals to MC. This part is equal to this part. So we'll write a reason. Perpendicular drawn from the center to the chord bisects the chord. Right? This was for the smaller circle. Now, if I'll tell for the bigger circle, again on a bigger circle, OM is a perpendicular drawn. So that is this OM will bisect the bigger chord as well. So from that, we'll get AM is equals to MD, right? AM is equals to MD. We'll mark it as equation 1 and the reason will be same and we'll mark it as equation 2. Now we need to prove that this part AB is equals to AC. So if I will take away this MB from AM, we'll get AB. Similarly, if I'll take away MC from MD, we'll get CD, right? So what we'll do? We'll subtract equation 2 from 1 and what we'll get? AM minus BM is equals to MD minus MC. So if I look at the figure, so AM minus BM is equals to AB. So it will be equals to AB. Similarly, MD minus MC is equals to CD. So it is equals to CD. And this is what we need to prove, right? I hope it is clear to you. Wonderful. So hence proved. So we have completed the question number 2nd, 3rd, and 4th. So in the next session, we'll start the question number 5th. For that, stay tuned. Bye-bye. Have a nice day.